Hello everyone. Today let's solve the problem number 212 word search 2. Right. So what the question states here, we are given a 2D board of characters and a list of words. See here, we are given a 2D board of characters, right? So see board, see this one I'm speaking of, right? And we have been given a list of words as well. See here, words, this one, oath, pee, eat and drain. So these are the list of words. We need to find all words that can be formed by moving horizontally or vertically on the board. What we need to find again? We need to find all the words that can be formed by moving horizontally or vertically on the board. Each cell can be used only once in forming a word, right? So each cell can be used only once in forming a word, right? So we have to return all the words that is found from the list. Again, we have to return all the words found from the list, right? So let me come here. Let me come to the approach part here. This is fine. Yep. Now, let me consider this first example itself. So you can just consider for the second example. I insist you to try out with a different one because second example we have words that cannot be found basically. Let's check the first one. So we have to return this one empty, this one empty array, right? So this is fine. So let's consider the first example. It's a full for the approach. Just follow this one, right? So this is fine. 1 second, just 1 second, man. Yeah. So let's consider the same example here. So we have this one board, we have words, we have, right? So first thing I want to tell you here is we will be making use of try. So this is going to be the last problem in the try, and next we'll be solving the problems on the graph, right? So for this particular problem we will be going with the try as well as the this one, what do we call, Mm, DFS basically. Try along with the DFS, just remember this one. So we'll be going with a try along with a DFS. Just give me a second, 1 second. Yeah, this is fine. Now first let's insert all the words into the try, right? So we will be inserting all the words into the try. This one OAAM, this one ETAE, sorry, we have to insert the words, right? So just oath, p, eat and drink. Sorry, I got confused, man. So here we have to insert all the words. So let's insert these words, right? So now we will start the DFS from each cell of the board. Example will be starting of will start at board 0 comma 0, this one 0 0, starting from O here, this one. So basically this one is 0 comma 0, 0 comma 1, 0 comma 2. Let me write this one 0 comma 3. Just give me a second here. So now we'll be starting from 0 comma 0. This first one is nothing but 0 comma 0, nothing but we'll be starting from O, right? So O here matches O. O here matches O. We are going with the this one, right? O first. First O. Next we'll be going with this one. What do we call? We'll continue DFS, right? So we'll go with OA, OAT, OATH, right? So first we'll be going with O. Then we find A here. One step left, one step right, one step up, or one step down. We can move with the DFS, with the help of DFS, right? So OA we have found. T we have found here at 1 comma 1, and H we have found. So oath we have found this one successfully, right? So this is fine, right? So this is fine. Now we will be going with the P basically, right? So we'll be going with the P. So let's go with the this one. What do we call? Uh, Anything. So first let's go with P here. Mm, P, we will search anywhere P, the letter P is found here. See, the letter P itself is not found. So P is not found here, right? So next let's go with the E here. E is present at 1 comma 3. So we will check with we only can move up, down and left, right? There is no cell at all, right? So we will move left. A is present, so we'll be moving left. So after A again we'll check whether we can move up or down. So we have A which is not required, and we have K which is not required, and we have T which is required. So see here we have found eat basically. So we have found oath here, this part, and we have found eat as well, right? 1 comma 3, 1 comma 2 and 1 comma 1, we have found eat here, right? So this is fine. We have successfully found the eat as well. Rain, we will check whether R is present on the this one, what do we call, cell basically in the grid. R is not present at all, so we cannot return this one as well, right? So eat and oath are present, right? So eat and oath are present. Basically, first what we will do, we will uh, this one create a try, and we will push all the words basically, right? So we will push all the words. See here. So this will be what do we call, oath, OATH. So this is fine. The second one is P actually, P This is fine. The third one is actually this one, eat. So this one is eat, EAT. This is fine. The final one is actually this one, rain, right? So I'll just go with rain, RAIN. So this one is fine, man. Yeah. So first we will start the DFS from here basically, right? So first words we will do this one. We will start the DFS. So we will be finding this particular word and this particular word, eat. So right. So this will not be uh, this word itself is not present in the grid, so we'll ignore this, and we'll ignore the rain as well. So this is how we will be making use of for this basically for the try, right? So again, we'll be going with the try and DFS as I've showed, right? So I hope this part is completely clear, man. Now as we are completely familiar with the approach, eat and try, eat and oath are the ones that we found, so we'll return the same thing, right? So if you are not if you are not able to find anything, so then in that case we'll be returning this one, what do we call, empty bracket, right? So this is fine, man. So let's do one thing. Now as we are completely familiar with the approach, let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would be pico of m into n into this one, 4 to the power of l, because m into n into 4 to the power of l, and the space complexity would be because sum of all the word lengths, right? So sum of all the word lengths. So this is fine. So the time complexity would be because m into n into 4 to the power of l, and the space complexity would be because sum of all the word lengths, right? So for the try as well as the recursion stack. So this will be this is due to this one. M and n is nothing but the board size, we know, right? So the time complexity, m and n is nothing but the board size, l is nothing but the max word length. So this is optimized by the tree pruning. Basically overall space time complexity would lead to because of m into n into 4l, and space complexity would be because sum of all the word lengths for the try as well as the uh, this one, recursion stack. So overall time complexity and the space complexity would lead to big of m into n into 4 to the power of l, and big of sum of all the word lengths, right? So we are done with this part. So let's do one thing. Let's as we are completely familiar with the complexities and the approach, we are good to write the code. Let's start writing the code, right? So now what happened to this one? This is not showing anything. Hey, why was it? This is fine, man. Let's do one thing. Hmm, we are going with the DFS as well as the try, right? First, let's do one thing. Let's go with the node of the try first. So I'll just go with class try node. So this is fine. So within the try node, let me give here try node children. So let's create the instance of try node here. This is fine. Let's pass 26 here because from A to Z, right? We can have the characters from A to Z. So we are just going with the 26 here. So let me go with the full word when we reach the end. So we have to store the full word when we reach the end, right? So for that one, I'll just go with string word. This is fine. Next, let's do one thing. Let's build a try with all the words. When I say this, I'm just saying this one, private. So this one will be try node build try. So this one will be string words. So this is fine. So this one will be try node. So this one will be root new try node. So this is fine. Next, let me go with the for loop here. This one is fine. String of words. This is also fine. So within the for loop, let me go with try node. This one equals current equals root. So this one is for the for loop. So this one is for char c w dot to char array. This is fine within the for loop. So we have to go with the index basically. So this will be c hyphen a. This is also fine, man. If we don't have the children, we have to create the node, right? So I mean, in the sense, if the node doesn't exist, then we have to create the node, right? So let me write the simple if condition here. If current dot children, let me pass the index. So this one is equivalent to null, then this will be current dot children of index. So let me assign this one to the, we have to create this one, right? So new try node. So this is fine, man. Next step is we have to move down, in the sense I will assign this one current to current dot children index. So this is fine. The next step would be this one. Let's mark the complete word at the last node, meaning, so this one will be current dot word. Let me assign this one to w, right? Finally, let's return the root. So I'll just go with return root. This is fine. Yeah. Next, let's do one thing. Done with this part. Oh, I have, just give me a second here. 1 second, man. I'll just go with this part. Just go with this part globally actually. So I'll just come here. This is fine. Yep. Now let's come to the main function. Let me just give me a second here. This is fine. Now let's do one thing. I'll just go with the list of string. This one result equals new array list. So this is fine. So the next part here would be, let's create the try from word list. When I say let's create the list, this is nothing but try node. So this one will be root. This one will be build try. So we have made use of the build here, basically build try, right? So the name that I have given. So let's make use of it within the main method or the main function. This one find words. So this one, let me pass the words here. We are just creating the try from the word list. This is fine. So now let's do one thing. Let's go with the this one, rows and the columns, right? So we have to go with the board length as well as the this one, sorry, rows and columns. So for m, I'll just go with board dot length, nothing but the rows, and for the column I'll just go with board of 0 dot length. This is fine. Yep. Now let's go with the step 2, nothing but we have to perform the DFS from each cell, right? So we have to perform the DFS from each cell. Let's do one thing. Let's write the helper method DFS, and then we can just go with the DFS here within the main method. So I'll just come here. Let me go with private void DFS. So this one will be char. This is fine. Board int I int. So this one will be j try node, and this one will be list of string. This is fine. Let me go with the result. So let's go with the boundary check first. This is simple. So I'll just go with I less than 0. I shouldn't be less than 0, right? So j shouldn't be less than 0 as well. So j less than 0, or this one, I shouldn't be greater than or equal to length of the board, nothing but board dot length. So this is fine. Or so j, same thing, j shouldn't be greater than or equal to board dot length as well. So let me copy this one. So this one we are considering column, right? So I'll just give here board of 0 dot length. This is fine. Next, yep, we don't have to return anything. All right, we are just checking the boundary here. This is fine. Next, let me initialize C to board of I and j respectively. So this is fine. Let's write the simple if condition. So if we have already visited, um, we don't have to return anything. If we have already visited the particular cell, we will be marking that cell and we are not visiting that cell again, right? So if we don't have any word, if we don't have any word that is present, then also we shouldn't display anything within the output, right? So let's write the condition for that. So if, so I can just write it on this way. If c equals hash means if it is already visited, hash or node dot children, yeah, in this case, so this one c hyphen a. So now if it is equivalent to null, so then what we will do, we will return, right? So this is fine, man. So if it is already visited or no word. So next what we will be doing, let's go with the node. Let's assign the node to node dot children. So this is fine. This will be c hyphen a, c hyphen a. This is fine. So now if we have found a word, then we have to add that particular word, right? So then we have to add that particular word and we have to avoid the duplicate as well. Let's go with that condition. If node dot word, when it is not equal to null, then we have to add that word to the result variable, result dot add. So what we're gonna add, so here we're gonna add the word node dot word. So we have to avoid the duplicate, so I'll just go with node dot word equals null. This is fine. So we are just avoiding the duplicate here. So then we have to mark the particular this one cell as visited if we have already visited, right? So this one will be board of ij. Let me go with, sorry, hash. We are just marking this one as visited. Let's explore four directions. We can go up, down, or left or right. So I'll just go with recursion here, recursive approach. So let me go with the DFS here. Let me copy this one, paste it over here, DFS. So this is nothing but board I plus 1 j node result. So this is fine. We copy this one, enter, ta, ta, 4 times. So first one we have already considered I plus 1. So next one I'll be going with I minus 1. So the second, third one I'll be going with j plus 1 and j minus 1 for the fourth one, right? So third one is j plus 1. And the fourth one is this one, j minus 1. This is fine. Uh, I cannot, uh, we can give here semicolon, right? So we're not writing within this condition. Yeah, within any condition. So this is fine. Now we are left with one last thing, that is nothing but we have to restore for other paths, right? So I'll just go with board. So this one, board of I and j, let me assign this one to the c, right? So yeah, this is fine. Restore for other paths, nothing but board of I j equals c, right? So this is fine. Yep, yep. We are done with this part, man. We are done with this particular part. Mm, then what shall we do here? 1 second. Yeah, now as we have completely written this one, what do we call the helper method DFS? Let's make use of it within the main function, right? So that I have completely forgotten. So let's start the DFS from, I mean, let's go with the DFS, or let's perform DFS from each cell, right? So I'll just go with for here, I equals 0, I less than, first we are going with rows, right? So m I plus plus. Same, let's go with the columns for this one has to be int j equals 0, j less than n, so this one will be j plus plus. J equals 0, j less than n, j plus plus. This is fine. So within the for loop, so let me go with dfs of, let me go with board comma I comma j, this one root, also let me go with the result. This is fine. What are the things that we have passed here? Board, ij, root, as well as the result. We have made use of the this one, what do we call, helper method dfs within the main method. So we are done with the, we're almost done. We are left with only one part, nothing but we have to return the result, right? So let me return result finally. So let me format the code once so that this looks nice, man. So this is fine, I guess. So let me move this one step. We are done with almost everything, I guess. Yep. Now let me hit the run button. I hope this works. Let's see. We have the oh yeah, I have misspelled the board here. Line number 28, 28, 28. So let me give a here, r here, pivot board dot length. Now this works. Yeah, the sample test cases are getting passed. So let me hit the submit button quickly. I hope this works for all the test cases. Let's see. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, man. Right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.